So yeah, today we're here to announce EdgeWise 5.7, which is, Justin will go through all the features and stuff, but we're excited to get this out the door. We've been working on it for almost a year now, behind the scenes. Started out with a Hack Week project, actually. One of our engineers did that just had really impressive results, and then did a couple more Hack Weeks. Thank you, Yuhong. And then just started rolling it into the product. So really, really excited about this release. Yeah, Justin, you want to hit the next slide? All right, so quick housekeeping stuff. Of course, all of y'all are muted for the presentation, but you can ask questions. There's a lovely little question section in GoToWebinar. You can go over there, type something in, and we will either answer it midstream if it's relevant to what we're talking about, or we'll answer at the end as best we can. And the webinar is being recorded, so if you have to pop out halfway through, or if there's somebody else that you want to see the webinar on your team, just have them go and register for the webinar, and anybody that's registered will get a link to that recording afterwards. So yeah. All right, next slide. Let's do some introductions here. So I'm Kelly. I am a Chief Strategy Officer here at ClearEdge 3D. Do a number of things out in the industry, but mainly I just spent a lot of time playing with laser scanners and trying to figure out what cool thing we should try and do with that data next here at ClearEdge. Justin, why don't you introduce yourself?
Hi, yes, I'm Justin Domer. I am the product manager for EdgeWise here at ClearEdge 3D. I've been with EdgeWise a long time, for about ClearEdge for about 8 years, and still do that sometimes apparently. And yeah, it's been exciting to see what we've been working on, and excited to show what we've been doing.
Awesome. And Merrick is here with us from NavVis. Merrick, why don't you introduce yourself, if you can. Oh, we lost Merrick's audio. Well, I'll give a quick intro while we resolve Merrick's audio.
We got it back. I'm going to get about the organizer because I was making noise in the background. So yeah, my name is Marek Kołtun, sales guys at NavVis here, based in New Jersey, working in the Northeast, focusing mostly on the AEC. Been with the company for 5.5 years. So I was able to see the whole transition from the first generation scanner that we had second, and now the VLX. The whole evolution.
Awesome. All righty. And that probably gives away a little bit what the main feature of 5.7 is. But Justin, why don't you take it from here?
Yeah, so the things we've been working on for 5.7 specifically, and just with EdgeWise for anyone who's not familiar. So EdgeWise is a scan-to-BIM tool. It's kind of focusing on automation and taking scan data and making it into intelligent 3D models for various workflows. We can do piping, we can do structured elements, ducting, walls, and conduit. But the big thing that we are kind of generally well known for is being able to automatically model piping from the point cloud. Traditionally, that was done as with a structured point cloud, so terrestrial data with all of the information of knowing where the scanner position was, and we were limited with our ability to process that data automatically if it was unified or if it was taken from a mobile data. So what we've been working on in 5.7 is actually being able to take in any scan data, so unified or mobile or any combination. If it's cleaned up, it's cut up, bringing in that data and actually automatically finding piping from that. So that's what we've been working on. We're very excited to show that. Additionally, 5.7 will support Revit 2023 and just help you model faster, basically. So that's kind of the main components. So the workflow that we've been kind of usually being able to do for EdgeWise has been taking your data, registering it, your terrestrial data, and then processing that through EdgeWise and getting kind of the modeling done inside of EdgeWise. And then you would take that original point cloud and you're going to cut it up, you're going to clean it up and cut it down to bring that into your final deliverable like Revit or Plant 3D or anything else you're working in, and kind of bring it all together there. with the new ability of being able to automatically extract from unstructured data inside of EdgeWise, you can kind of fit that a little bit differently in your workflow, where you take in your data, whether that's mobile or terrestrial or a combination or any variation, you can cut it up and clean it up however you normally would for your workflow, and then bring that into EdgeWise directly. So instead of having to bring in your enormous point cloud that has, you know, all the structured information, which is generally going to be a lot bigger, you can bring in just the portion and the area of the modeling that you need to do and bring that directly inside of EdgeWise. So it's kind of a much more direct path in your workflow overall. And the nice thing is that unified data is going to be a lot smaller, just less data that you need to worry about, as well as, again, you can just cut up the specific area that you care about and what you want to process, and that's what you bring inside of EdgeWise. So this is something we're really excited about, but yeah, it just kind of opens it up. The one thing I will say is that decimation is going to be a factor. So we still don't recommend decimating the point cloud down too much. That will affect the results. But if you're just kind of cutting things apart and sectioning things out and getting rid of noise and unnecessary points in the point cloud, then that can be really helpful for the workflow. The next thing is just, you know, why did we do this? So why did we actually decide to go through this process? It's something that was been requested for a long time. This is something that, you know, users have been requesting because it just makes a lot of sense for being able to take in that data, especially if you're receiving data from somebody you don't have control over the scanning, you don't have control over the format, and then you're already cutting it up before you bring it into, you know, whatever you're doing. And then the other major part is the emergence of mobile scanning. So over the last few years, you know, NavVis has really brought really incredible data quality for mobile mapping. And so that's something where now with EdgeWise, not only are we doing really well with taking in terrestrial data that's been cut up and cleaned, but we're able to take in NavVis data directly and get equally good as results. So this is something where being able to take that in, you can scan so much faster, and now we can process that data and you can model faster from it too. And you know, kind of showing up with mobile mapping becoming so popular. There's a little bit of an echo. So at this point, what I'll do is I will pass this off to Merrick to actually talk about NavVis and cover, you know, what they do.
Perfect. Thank you very much, Justin. And again, thank you, Justin Kelly, for inviting me here today. You know, the idea is, as I mentioned, I've been with the company for over 5 years, and we always had speed. But you know, speed is not the greatest thing. You know, if you don't control your car or if you don't get good quality data, because you can get in trouble in both cases. So we are very happy that after, you know, 5 years, it was actually 4 years maybe, because for the last year we've been getting much better data than before. We moved from what we were promising at about 1 inch of accuracy to about 1/4 inch. And when we go to the next slide right now, you will see the biggest trade-off that we get. You know, getting data fast is just a part of the equation, because at the end of the day, what is the biggest cost driver of getting data and working with data? Is the labor. Time on site, man hours, multiplying by average hourly rate, and you get a price per square foot. And that price per square foot was a major blocker for people to work with the data and open laser scanning to new verticals and new use cases that they weren't able to use before because it was just economically not feasible. So scanning a building in 1 day versus scanning it in 5 or 10 days makes it easier on a client, because you're not in their hair if they have any for, you know, for a week or two, but you can also get it done quicker, get it done faster, get it done safer. So as we move to the next slide as well. Yeah, using NavVis, we never promised that NavVis is a tool that can get all the jobs done. There might be some companies who say, hey, I have a magic wand that can do everything. And as I say, they either come from the future or they just really want to sell you their product. The most successful clients that we have learn how to use VLX and combine it with all the other tools out there. So if it's a terrestrial scanner or a GPS or total station, you can still use and work them together. And using the right tool for the right job is the key to getting the best quality results in the best possible price point that allows you to get the most data. And as we move to the next slide. Yeah, we'll just have a video that will play to give a basic overview because our technology is very visual. It's very hard to explain it with words. And seeing a couple of photos, couple of videos will allow to understand for people more what our mobile scanning is all about. Because a lot of folks still have a bad stigma when it comes to mobile scanning. And they're totally correct. Because as I mentioned, for years, mobile scanning was far behind static scanning and it couldn't even touch it with respect to quality and accuracy. This has all changed with the VLX. We had the M3 scanner, which was big and bulky, could only be used inside in finished buildings. Then we had an M6, but it still wasn't a great tool for process industry construction sites and taking it outdoors. With the VLX, we can literally take it anywhere. We even have people who climb ladder cages wearing the VLX on top of their shoulders. I probably wouldn't be able to fit there myself, but 80% of my clients are probably fine and they have more experience climbing those ladder cages. So we've done a lot of studies showcasing scanning buildings with a static scanner versus the VLX, and it all comes to the use case. If you're doing heavy engineering work where you really need to prefabricate some crazy units and it needs to be super accurate, then yes, you should still use a static scanner. But if you're doing as-built, existing conditions, anything where about 1/4 inch or 4 to 5 millimeter accuracy is good enough, then the most logical tool is the tool that is most efficient with your time. As we talk about getting data, you can get a lot of data and you can get super accurate data. You can have super nice camera to take photos, but in a daily life, everyone pretty much uses just their phone because you don't need to have a photo with 100 megapixels where you can see all pimples in my face and then somebody needs to Photoshop it. So you can get overwhelmed with data, how dense it is, how heavy it is. It's just gonna crash your computer if you don't have enough RAM. Having lighter data and getting their data more often, repetitive scans every week or every month, because now you can do it, it's the key. And how you filter through all this data, this is what we will discuss in a bit today. But yeah, getting the right data for the right project is what we've been pushing, and we are very proud to showcase what we are getting. So the video already showed the point cloud quality that came out from the scan that my colleague is doing right now. And then you could see how fast she could just walk around the building, and anyone can pretty much put a VLX on and go and scan and get their projects done. And it's not just scanning, it's the cloud processing and all the other benefits that I can scan, entire Empire State Building and a World Trade Center and process them both overnight in the cloud. And this is not something that static scanners can do. I can literally process 200 floors in 16 hours. But yeah, as we move to some of the use cases, besides the AEC, which is our biggest use case in construction, architecture, and other engineering work, VLX has really opened us up to the process industry. We didn't have a form factor, we didn't have the size, we didn't have the data accurate enough to deal with a lot of piping. And as we know, ClearEdge is what helps people the most. One of the main use cases is working with pipes. So we are very happy that VLX actually opened us up to the collaboration together that we couldn't do before. So when we talk about the process industry, we have multiple clients and dozens of VLXs already deployed in the field all around the world, scanning refineries, different plants. And it comes through the whole life cycle of the process industry, from extracting to processing and to delivery. So as we go to the next slide, those three will be rather quick. We already have existing work that we started probably 2 years ago, just a few months after VLX came out, when folks were already verified in the field how the data looks, if it's accurate enough, if it's clean enough, if it's filtered good enough that can be imported into their typical tools. So we have the 3 main groups that we are working with. And this could be, the owners, operators, the engineering teams, and the subcontractors. We call them LSPs. They're laser scanning professionals or scanning consultants, or essentially anyone who offers scanning as a service. They pick up VLX as another tool, and they offer scans for their existing clients. And then as I have 3 more slides to go through, because I do believe that they will just showcase, what our clients are doing already and what problems we are solving with the VLX. Being in those environments, any new technology, as my mentor Matthew Craig says, needs to be better, faster, cheaper, and safer to succeed. Because if you're on an oil rig and you need to be there for a long time, you just expose yourself to potential risk. The longer you are, the bigger the risk. So it's not only about getting better data, but minimizing the time on site, you're minimizing the cost, you're minimizing exposure to some weird chemicals that might cause some trouble or any other things. As we move to the next slide, that it just shows some of the use cases that we tackled in the midstream part. That the as-built documentation for a lot of plants, especially in the US, that are very old, just doesn't exist because it was so costly to create those as-builts. Sending somebody with a static scanner for 2 weeks would just cost exponentially more than sending somebody with a VLX for 1 day to capture the same site. And in this type of environment, because there's so many pipes, so many little things, so many nooks and crannies, having a static scanner, you have very limited line of sight, a lot of blind spots, a lot of occlusions. Walking around with a mobile scanner, you have a lot of loop closures, figure eights, and you cover all those pipes, all those tanks from thousands of different angles, and then the point cloud is very complete, very easy to digest. And the last step, this is exactly where I started, going into large complex plants, being able to walk through as quick as possible, turn around data quick, allows us to get the data delivered faster, cut cost, and give more data to the client that previously maybe they wouldn't capture because they would only afford to pay for the very mission critical part of the plant, maybe 20%, and the 80% of plant would go unscanned because there was no justifiable need to scan the whole plant. And right now, when the price of square foot is more attractive, they can scan the whole plant and they can keep rescanning. So you don't need to scan once a year. You can scan once a quarter. You can scan once a month. It's the same thing with internet. When we had a dial-up, price per megabyte or price per minute was very high. Now price per minute is unlimited. And like when there was more money in the internet, in the 90s or right now, something from $1 billion industry or multi-billion went to multi-trillion. So the only way to bring the laser scanning industry up, we believe it's gathering more data faster and more affordable than ever before. So all our providers are more busy gathering data, and then companies like ClearEdge can create solutions to add value to the data so people can work with more and digest more data than ever before. And that's pretty much a quick overview of what we do at NavVis and what our focus is.
Awesome. Thank you, Marek. Yeah, so that is a great example of the ability that the market is going, and what NavVis is doing is just being able to collect so much more data, so much more quickly, and still have the quality, which is the important part. So being able to have that precision and that accuracy along with the speed is just an awesome thing. With that, we have if you're collecting lots and lots of scan data for lots of big facilities and different industries, then you need to in theory you need to do something with that data, and that's why we are very excited about being able to support the unstructured data, because now we can actually go through and do very useful things with that and get it to you quickly. So this has been something where we can take that VLX data, and then with EdgeWise, this new release with 5.7, we can combine that all together and get models much faster than pretty much ever before. So at this point, what we'll do is I'm going to show a couple of data sets that are just from various users and customers that we work with, as well as from NavVis, and just kind of go through some of the workflows and some of the examples of what EdgeWise can do, and just kind of the high level for the workflow. So what I'll start with is a NavVis data set that we have. So this is a smaller data set, but this is one of the sample data sets from NavVis. And this is something where we can go through, and we basically brought this little point cloud in. We processed it with EdgeWise and using kind of just the defaults from what they're doing. And this is our little model that we got. So these sections here, we are extracting the piping from it. We're going through and creating it. We can still do our normal workflow where I can go and actually grab a section of piping here, and I can look at how the quality is. And we see that there is good quality. They have just really good noise reduction for what they're making, and we're able to extract pipes from it basically. So for this data set, we can go through, and this is just a small one from NavVis specifically. But we have our normal workflow where I can do easy connect. and fill in those sections and try and connect things. And I can go through and basically, add our normal workflows in. But this is a smaller example from NavVis, but we have a couple ones that I have up just to kind of show it. See, this is another one from NavVis as well. So this is a process plant. But again, it's kind of going through. We can see that we're extracting the runs here, and we can actually run that Easy Connect and kind of fill in these sections. The data that we can work with is, it's anything that you have. So if you have point cloud data that is, with the right amount of noise, so lower noise, so that's something where we're getting really good results from. One thing we're going to be working on is trying to get settings that work the best way possible for different data types. So we're going to be working with NavVis on getting different data sets and trying to tune the extraction to work best for that. And that's something we'll be doing, over the course of the next couple months, is just trying to get more settings and more options to get better results for working with this. But we've gone in and filled it all in. You'll notice there probably, if you are familiar with EdgeWise, that there is a lot more of these kind of little sections. The way that the algorithm is working is we're doing smaller chunks that we're kind of using Easy Connect and leveraging that to fill in. But we have our normal workflows where we can go through and I can extract anything that was missing, individually. So in here, if I want to extract a section of piping, I can go and draw a box around it, and EdgeWise will find that cylinder and connect it up.
And for those less familiar with EdgeWise that are kind of seeing it for the first time, just to point out what Justin showed on the screen here is the fully automated, basically click and forget. This is what you get with zero human man hours. You basically get to the point that we're showing here, and then that Easy Connect basically helps you stitch all those pieces together.
Yeah, and for this data set took, I think, like 30 minutes to run, something like that. So it's moving fairly quickly, and we're getting kind of the main runs here. So the overall workflow is you take your scan data, so if that's from NavVis, you download that, and you pass it into EdgeWise, and you say, go find cylinders. And at that point, we'll kind of go through that automated pipe extraction process of taking those cylinders that were automatically found, filling it in, and kind of maintaining the as-built conditions. So one of the important parts here is if we look at these sections of piping, they are not straight. So we are doing as-built conditions that are automatically being created, and pulling that from the NavVis data. And then from here, it's filling anything that wasn't done automatically, and it's actually going through and before you export to your various locations. So we've talked a lot about NavVis. That's definitely a big part of it. Is that the ability to take their scan data in directly is just amazing for the quality of from a mobile scanner. But the thing we're also excited about for EdgeWise is just that this isn't limited to just a mobile scanning process. This is just any data. So like a lot of people, you're going to have your scan data, you're going to cut it up, you're going to section it, you will decimate it. I think there was already a question on decimation. The more you decimate, the less points that we have for EdgeWise to automatically extract things. So we would recommend, we're still figuring out exactly how much decimation we can get away with, but generally the more points, the better for the algorithm to figure things out. So we would recommend, not decimating very much if possible. We're kind of hoping that by clipping away a lot of the data and making it unstructured and unified, that will save a lot for the size of your data that you're processing and having to transfer and move around and things like that. But it's, that is an important part. This data set is a terrestrial scan, but this is provided by one of our users, ENG. They work with this data set a lot, but this is a really cool one where we actually process this and see, this processed in, I think, like 40 minutes, something like that, 30 minutes. And we get a lot of stuff extracted. One of the things that's also been added for EdgeWise, so we had these little tiny, these are actually the hangers, so it's fairly sensitive for doing this, but in this case, obviously, these are not pipes. We actually added a filtering option in the new algorithm, so we can go through and remove diameter sizes, so it's something that can go in so that you don't have to delete those manually. So that was another feature we added in process scans. But that's something where it's going through and extracting as much as we can, and that's kind of the core workflow. It's just sitting for a long time, so we'll see if it's thinking I have a lot open. So I guess that's probably it. This is what I was talking about. So this allows us to, in here, we have this little option to remove sizes. So this is just part of the new extraction. That way you can get rid of things. So it's just trying to help with filtering. But yeah, this is kind of a cool process for it, but we'll go through and I can run Easy Connect on this one. It takes a minute as well, but this is what we're doing to save time. You know, this is the whole key, is just being able to work with this data and bring that in and you know, just use it with EdgeWise like you normally would if you're an existing user, but whatever data type you want. So yeah, I think that's kind of the core part of it. At this point, what we'll do is kind of shift into some other numbers. One of the big questions that has come up is processing time. That's another big factor with EdgeWise especially, is that we're dealing with lots of big data sets, and how long it takes to process that data is a critical part of the workflow. And so with this, one of the things that we're really excited about with the new process scan algorithm is actually that it's also fully multi-threaded. And so one of the key parts is that in the industry, just like mobile scanning, which has improved substantially in the last few years, processing power in computers has also substantially increased. And so having more cores and having, you know, faster RAM and faster CPUs and everything else is something that we are very happy that we can say that we're taking advantage of with actually going through and you know, being able to process this data more efficiently. So this is kind of another look here, but again, this is just the, you know, kind of raw process. We can go through manually, fill in anything that wasn't done in here before exporting it out to wherever we're going to export to, and just to cover that a little bit, so we can go to Revit. We have all of our other exports, so we can go into, and we're going to be adding some more exports. We'll talk about that in a little bit. So that is kind of the demo portion, but of showing some of the results and everything else. We're excited to hear from people to see how their results are. EdgeWise is posted, so this version is up on our website. If you want to go to ClearEdge3D / I think updates or software updates, that's under the support section. You can download 5.7 right now if you are an existing user and try it out for yourself. But to skip over that now, what we'll do is just talk about some numbers. So this is just some graphs that we have for processing time to look at some different examples and specifically compare the unstructured algorithm versus our traditional structured workflow. So the original algorithm was partially multi-threaded, but there's a lot of steps that aren't. And so it doesn't take advantage as much of the CPU as it could. And so the new algorithm is fully multi-threaded and it's working through that. So in this case, what we did is we have this is actually our original demo data set that we have, that industrial plant one, where we took it like when it's fully structured, it's a native files, it is 10 gigs. And then I just took that into recap and just hit the unify button and spit out a recap file that was fully unified for that same exact data set. So no decimation for that. No clipping or anything in this case, just because we wanted to show the numbers to compare the algorithm specifically. But we can see when you have the goods, just went back on me. When you have a great computer, so this is Kelly's machine, it's ridiculous and I love it. But you know, as we're seeing, we do have, it's interesting with like the smaller 4-core, so quad core, we don't have as much advantage just because of the raw processing power. But as soon as you start throwing more cores at it, it goes faster. So in this case, we did that industrial plant process, you know, that traditionally takes at least an hour, and you know, on a machine that's more powerful, we're getting it down to 20 minutes. And so that's the sort of thing where, you know, we are actually getting a full advantage of using these really powerful machines that are out there. And so that's something we're very excited about, just because, you know, time matters a lot. That's why we're here. That's what we're doing, is we're trying to save as much time for this. And when we're able to collect so much more data with mobile scanners, being able to quickly process that is a huge part of the workflow. So this is just a small example. We also did some time testing for bigger scans that are probably much more normal and used by for the size of projects that people would be used to. Same concept is we had the original data. In this case, it was about 200 gigs of PTX data. And then we unified that exact same thing, pretty much just a straight one-to-one, but unified it, and we ended up with a 97 gig file. So kind of the same idea. We have two powerful machines, right? So these are, this is something that we didn't want to spend a ton of time doing the processing. But again, it's just, it gets faster when you throw more cores at it. This data set specifically we've had for many years, and on an i7, a quad core CPU in the last 5-6 years, this would take us about 48 hours to process with the old algorithm, with the hardware that was kind of present. And so the fact that we're doing it in 7 hours versus the 48 is something that we're really excited about. So for the amount of data that was processing and just the processing power, we definitely like the fact that we can cut that time down as much as possible. Okay. Okay, cool. Yeah. So I think they posted the link for in the chat for people to go download if they haven't done that already. So that's the numbers. That's a big part of it. The last few things we'll kind of cover are what are we doing next in EdgeWise. So this is already released. So 5.7 is out right now. Again, that has the unstructured algorithm and then support for Revit 2023 and a bunch of bug fixes and other kind of improvements in there. But for what's coming up next, so the next release of EdgeWise is going to primarily contain an E3D, Viva E3D export. So what we're going to be doing with that is actually going through and creating macro files that work in E3D. We'll start with intelligent structure. So we've kind of redid how we're doing that and how we're going to get that conversion done, but the macro can be imported and it'll kind of directly make native structural components inside of E3D based on what you made inside of EdgeWise. And then we'll also be doing a piping export as well. This will be a primitive geometry export for E3D, where it's just kind of the position of the piping without the straight intelligence. Depending on what people are requesting after that, we can go through and we'll see what we end up doing. If we want to do a intelligent piping, if that's what customers need, then that's something we would be interested in doing as well. But this is going to be kind of the next release in 5.8. Other things that we're looking at doing is going to be, as I mentioned earlier, just trying to tune the algorithm as much as possible for different workflows. Right now, the way that the process scans filtering that we've created is set up is it's more of a generic tune, and it's more focused on terrestrial. Now, the cool thing is that we basically tune it for terrestrial data, and then NavVis data is basically terrestrial data for all intents and purposes inside of EdgeWise. So we don't have to do, we're getting really good results now, but we know that when we work with them and work with more data sets, we basically want to create settings where in process scans, you can say this is NavVis and select that and get the best results out of automatically extracting pipes as possible. And we want to do that for lots of different workflows and different hardware. So that's something we'll be working on kind of periodically over the next year to continue to add better filters for specific hardware and workflows just to get the best results possible. And so we're excited about that. We know we have some headroom for improving the processing, and that's something we excited to also be able to do is just get those the results to be even better depending on those process that you're working on. Some other small things. So we're going to be kind of doing our Plant 3D plugin a little bit more integrated into actually having the button and everything else, and then we're going to be doing IFC exports as well. And then mixed in here, we also are planning on doing bug fixes. For a lot of this stuff, this is something we're excited about. Just being able to work more in EdgeWise and kind of fill things in and get some more features and improve the workflow as much as we can. Okay, and so to kind of wrap up at this point, we have just going back through it. We're really excited for the fact that mobile scanning is where it is and up and coming. NavVis is doing some incredible stuff. And for us at ClearEdge and with EdgeWise has always been agnostic for the data. And so the more data that people can have that's good quality, the more excited we are because we can basically bring that in and get good results. So we're trying to increase the accuracy and speed up the delivery time so that people can take more projects and you can basically take in all that scan data that you are collecting and do something interesting and useful with it. So You know, that's the big portion of it, is using EdgeWise as we always used it, but now it just opens it up for a lot more workflows. And so, yeah, at this point, that is pretty much everything that we have for the presentation. And I think at this point, we'll just switch over to the questions.
Yeah, and I've got a couple queued up here. I did answer in text form, but Justin, could you talk a minute about you know, other types of things EdgeWise extracts and how that fits into the overall modeling workflow?
Yeah. So for EdgeWise, the main, you know, in this case, we talked a lot about piping. For the workflow, we can also extract lots of different things. So we can do structure. So if it's steel or concrete, kind of industrial steel, that's something we're able to automatically extract in some workflows, and it's fully intelligent. That's a big part of it. We can do ducting systems, so round and rectangular ducting, cable trays, and we have walls as well. So a good assortment of kind of the parts of the work, like the building, that they're everywhere, and you got to fill in a lot of stuff. So we're trying to make those tools specifically for automatically doing those as much as possible. And then also it's purpose-built tools. So EdgeWise is a software that's designed to take scan data in and make it into intelligent models that as a middleware. So we can export to lots of different places as intelligent objects, but we're just trying to speed up that workflow for modeling all the big stuff.
All righty. We have a question. What is the relationship between ClearEdge and NavVis? I'll let Merrick take a pass at that too, but short answer is we're just two companies that you know, we really like the NavVis product. We're super excited to see it on the market. We go to all the same trade shows, and I've known Merrick for many years, and so when the VLX came out, we got really excited, and basically the relationship is we like each other's products. And that's why we're here today, you know, talking about this, because it's a pretty big game changer in terms of just the things that can be scanned in a reasonable amount of time. Opens up projects that just didn't make sense before with terrestrial scanners. And, you know, that makes us happy. I'm sure that makes NavVis happy. Merrick, do you want to add anything to that?
Yeah, exactly. Because, you know, when you think about NavVis, we focus on a step one, which is reality capture. And as soon as you get a point cloud processed as an E57 or RCS or PTS apply, like, we cannot really help you with any other stuff. So we focus on the step one, which is gathering data. And then we like ClearEdge because you can absorb our data and add value on top of it. Because, you know, we as NavVis, we are not Autodesk. We don't create Revit. We don't create any software like this. So we need folks who take our data and they allow users to work with the data. And the more data they gather, the easier it is to work. The more value they add, the better for everyone.
Awesome. All right. We have another question about virtual machines. Justin, does EdgeWise support deployment on virtual machines?
That's a good question. So it does. You know, there is licensing options for doing that. And one of the things that we actually did for an experiment was spin up just a beastly AWS VM for like an hour that had 64 cores, and just to see what it would do. So basically putting the data on there. If you're doing virtual machines, generally the CPU core clock speed is going to be lower. So there is a trade-off where, you know, yes, you have 64 cores, but if it's going at, you know, 2.5 gigahertz, you lose a little bit of the linear value of doing that, but it does support it, and you'll get it process data faster if you have more cores. That's just kind of the general gist there.
Yeah. So Justin, how many more or less pipes are extracted with the unstructured algorithm versus the structured algorithm?
Well, that's a good question, an important question. And so we are getting similar results. I think in today's algorithm, the most recent, you know, kind of the first iteration of it, I think the structured workflow is slightly more pipes. It's a little bit more. So, you know, we're hoping we can kind of continue to tune and improve that. So there is a little bit more pipes extracted if you do it with the structured workflow, but that is still very limited because you can only do it with this structured point cloud. So we'll see how the questions go, but I might be able to show just two different data sets from structured and unstructured and show that, because that's been a huge portion of how we're basically judging this, is how good is it compared to our original algorithm.
Yeah, it's one of those things where having looked at this from a little further back than Justin, and looking at the data sets, at first glance, it's really hard to see much of a difference. When you really dig into it, you can find some things where the unstructured algorithm missed a few things here or there that the structured algorithm did. Then again, the structured algorithm has had, almost 10 years of continuing development and improvement, and our unstructured algorithm is basically a 1-year-old baby. So plenty of room for us to improve it, make it better, and we will, continue to do that over the next couple of years. Yeah. And then actually I had another fabulous follow-up question. How would you deal with overhead or above ceiling scanning? Is the NavVis plus EdgeWise combo capable of accurately capturing that sort of data? So Merrick, you talked about, in plant environments where you have lots of pipes, how good mobile scanning is in terms of, dealing with occlusions. Are you guys seeing the same things with above ceiling capture?
Yep. So, I mean, if you go and you have the ceiling tiles that you can open, it's actually very easy to work with the VLX. You hold it in your hand and you can either stick it up yourself if the ceiling is low enough so the head of the scanner can reach there and see up there. If not, you just have to bring a little stepping ladder and go like this. But yes, it's super annoying. You have to open as many ceiling tiles as possible. The good news is that the SLAM holds up. So you have two lasers, one in the front, one on top of your head, one in the front, and the front one keeps spinning as well. So it keeps orienting itself under the ceiling and you peeking over the ceiling. So while you still hold the SLAM attached in a room and the location of the device is known, you go up and you start spinning around there. So it allows to scan much faster. Obviously, the line of sight is what you can see. So if something is blocking it, even a piece of paper, you will not see through. So that's why you have to open as many tiles as possible and just literally peek a scanner in for 5 seconds, kind of rotated left and right, and it's not gonna be a full sphere. It's gonna be more kind of like a triangle shape because the laser has an opening of like 30 degrees. So if you tilt it left and right, you'll probably have 60 degrees. You will not see directly above you. Then you have to look from below the opening. But yes, we have some data sets that we can send of a quick scan of a medical lab with no ceiling tiles, some ceiling tiles, and a lot of ceiling tiles, so folks can see how it performs.
I will point out it's a lot easier for Merrick to get above ceiling scans with the NavVis than it is for most people. But if you haven't,
I'm cheating.
Very tall. And just EdgeWise, why don't you talk about the EdgeWise side of that in terms of dealing with occlusions and things? Because I know it's one of the reasons our customers love using EdgeWise.
Yeah, so one of the ways, there's a couple pieces for that. One of the things is that we don't need to see the entire outside diameter of a pipe to get it. Generally, 30% of that pipe or 40% is enough for us to recognize it as a cylinder. And then the other part of it is that, in that, you're always going to have kind of those blocks, those occlusions that are in the scan data shadows. And so the way that EdgeWise works is we're individually finding, cylinders throughout the whole area. We're just looking for cylinders everywhere. And if there's occlusions, you'll see, a pipe on one side and a pipe on the other side. And then that Easy Connect tool that we saw, that's going through and seeing those two cylinders. They look like they're in line and making that and filling that connection in. So we'll try and do that as much as we can automatically. And then there's tools that you can go through and fill it in as well for whatever that doesn't get done automatically. One thing that we also really like is that, especially for that sort of workflow, is that obviously, you can go through and you can scan tons of things. If you need high precision stuff, if you need something a little more detailed for specific areas in the project, because it's unstructured data, because we can work with that, you can take, and mix scanners together. So you can have having that and then bring all the data together and export it out as one single point cloud. And that works great inside of EdgeWise as well. So, having that option for being able to mix data types is really nice because you can use different workflows to fill it all in together. Let's see, yeah, we got more questions here.
Yeah, let's see. How much point cloud cleanup time is required for SLAM scans to be able to get the point cloud to a good point for EdgeWise? Fabulous question.
Yeah, great question. So to answer that for the NavVis side, I did nothing. I downloaded it from NavVis directly, and it was just the default. I didn't do anything. So those data sets, you know, their filtering, their algorithms have been really, really good for working with it. We just download it off of the site and run it, and that's pretty much it. The cleanup that you can do, as far as you know, the only real cleanup is if you just only have one area that has pipes in it or has walls in it that you want to extract, and it's just cutting away, you know, with kind of the area that you really, you know, need. So, but as far as filtering, as far as anything else, like, we haven't really needed to do anything. Which has been pretty amazing. Past that, I mean, yeah, if you want to go through and cut away people, if you want to do things like that, you know, that's in the point cloud, that's not going to hurt. But at the same time, EdgeWise is just looking for cylinders. It doesn't really matter that much if there are, you know, other things. It's, you know, it's kind of personal preference on what you want to run. But because we're able to do this, you know, if you want to go through, you can kind of treat it how you would go into Revit potentially, or wherever you're modeling. Is whatever your normal cleanup for that is, that's probably plenty for this. It is still the statement of decimation. So if you're doing really heavy decimation, normally for when you bring it into Revit, we wouldn't really recommend that. The results aren't going to be as good as if you do keep the density higher. But, you know, a normal 5 mil decimation, we haven't seen any significant, you know, too major of an issue. If you do like a 50 mil or 10, you know, 20 mil decimation, that probably will, you know, impact your automatic results.
Yeah. Another question: is there a possibility of this being used with subsea data, so presumably underwater LiDAR or photogrammetry data? I'd love to see a VLX wrapped in you know, with a scuba suit, but I don't think the VLX is waterproof. But in terms of the EdgeWise side, yes. I mean, yeah, essentially, by opening up all of our modules, which some other people asked earlier questions about, you know, what about structural extraction, which EdgeWise is also known for, or what about, you know, rectangular duct and cable tray and some of our other modules for things that we extract. Basically, piping was the last major module that did not support unstructured data. And this is where we run into nomenclature problems, structured data versus structural extraction. But our structural extraction module has supported unstructured point cloud data for a very long time. And so, you know, now we basically work with it across the board, with the exception of our terrain extraction, which almost nobody uses because most people come to us for other things. But basically all of the main systems and structure modules now work with unstructured data, and that could be photogrammetry, it could be mobile data, it could be terrestrial data that's unified, it can be you know, data coming from subsurface applications, from subsea applications. It doesn't really matter if you've got point cloud data, as long as the accuracy of that data is sufficient that the algorithms can actually recognize a cylinder or a structural shape in that data, the algorithm works. And so, yeah, definitely can work with that. Yeah, let's see. And just to add to what Justin was saying about cleanup, technically, even with terrestrial data, we don't necessarily recommend a lot of cleanup before coming into EdgeWise. EdgeWise, the algorithm is not as sensitive to noise in data as human modelers are. And so this is one of the interesting things, right? You know, algorithms and computers, we're trying to do what people do, but, you know, computers are strong at different things, and people are strong at different things. So, you know, in terms of just having noise and cars and people and things walking through the site, none of those things look like pipes. And so it doesn't really bother the computer if those things are there. So EdgeWise itself doesn't tend to be, and the same thing's true with Verity and some of our other applications. The software itself is not really sensitive to noise in the data. You probably want to clean that out so that when you hand it off to your human modelers, they don't have to deal with that. But yeah, EdgeWise itself, you know, it's not that big of a deal in terms of cleaning it up. let's see. We've got a question about renting time on the software. We do have short-term license rentals of EdgeWise. So if you don't do that many piping projects, but when you get one, you want to use EdgeWise, we have, a monthly license. We have, things like that. So definitely reach out to our sales team on that. Let's see. Does the software recognize insulated piping or equipment or structural profile? Are you using any AI or machine learning in the above process? Justin, I'll let you.
Okay. So as far as the processing that we're doing, there is no machine learning or AI yet. That is something. This is just pure computer vision. Again, shout out for the development team. They have done some pretty incredible stuff. It is just straight up black magic. But they've are just looking at the point cloud and able to extract pipes from that directly. We are interested in using, basically for tuning. That's something we are going to be looking at, is seeing if we can leverage machine learning to do tuning and kind of work with the, for getting those filters. So how we're doing that is still, lots of things we're looking at, but the goal is just, again, to just get as many filters that work as well as possible. But for right now, it is just straight computer vision.
And then in terms of the insulated and piping stuff, so the laser scanner doesn't know whether or what it's looking at is an insulated pipe or not. So this is where human operators come in. The way I always like to describe the value proposition of EdgeWise is it gives you a head start. EdgeWise doesn't finish anything for you. It doesn't replace having a modeler that actually knows the scope of work on your job. What it does is it makes that person way more productive and efficient, because basically what you just saw on the screen there is what they start with, rather than just the point cloud. And so you need that person who knows this pipe is insulated, or it's this kind of pipe, or this is a kind of getting some background noise. So basically, EdgeWise is here to give you a head start. It's not here to, push a magic button and you have a piping model and everything's done. Equipment is not something that's easily automated. Maybe with machine learning, we'll get there someday. But we don't focus on those things because you need to take this into your authoring application anyway to do your documentation or your re-engineering or whatever it is. So our goal is to find things like piping that we can highly automate and rapidly get you most of the way there on, and then to facilitate you getting that into PDMS or Plant 3D. We're working on an E3D plugin. We should have a beta for that soon. As Justin said, we've got IFC, that we're working on. So, we want to support getting these things out in an intelligent way into the different downstream applications that you'll use to add equipment, add pumps, add, whatever, develop your PNID drawings, all that kind of stuff, if that makes sense. And with that, we've got about 3 minutes left. We will try and answer any questions that we didn't get to. We'll try and answer them, either offline or just, follow-up emails, things like that. And otherwise, thank you, Justin, and thank you, Merrick, so much for joining us. It was a pleasure having you here. As one of our attendees noted, the tallest man in reality capture in North America. Thank you all for coming and listening. Really, really appreciate it. Please follow up with Merrick and the NavVis team if you've got more questions on the VLX or the M6 or any of their hardware or software platforms. And then obviously, please follow up with Justin, myself, or the ClearEdge team with any other questions about EdgeWise and what it can do. So have a wonderful rest of your day to everybody.